Hello and welcome back to CST 3130. So in this lecture I'm going to cover a structured query language, or SQL as it's usually known. So previous lecture kind of introduced you to relational databases, explained what a relational database management system was, and the basics about tables, primary keys, foreign keys. This lecture I'm going to cover the structured query language, or SQL, which is used to store and retrieve data to and from relational databases. Now there's a sort of set of core kind of SQL commands like, insert, select and so on. And these are supported by pretty much all relational database management systems. And then sort of around the fringes they may introduce some of their own sort of tweaks or additional stuff. But for the most part, you can assume that, everything I've covered in this lecture certainly, but pretty much, the majority of SQL will just run on any relational database management system, MySQL, MariaDB, Postgres and so on. Interestingly, I came across this IEEE Spectrum list of top programming languages yesterday, 2023, and turns out that SQL is, regarded as, one of the top programming language for jobs at least, yeah? Although they kind of qualified that by saying, yeah, if you're a master of SQL, great, but what they really want is to see you able to use SQL in conjunction with something like Java, JavaScript, Python, and so on and so forth, yeah? So the idea is, once you create a database, and you create your database with SQL commands, but I haven't covered this in this course, once you've got your database, you can use SQL to insert data, select data, update data, delete data, and so on. And so you can do that sort of within the graphical interfaces that can talk to SQL, like that can talk to relational database management systems like Heidi, or whatever I think MySQL Workbench I think it's called. You can also put those SQL commands into your programs, like a JavaScript program when you're building a web service for Coursework 1. You're going to build kind of SQL commands and run them on the database, yeah? And the database dumps, the way of storing and backing up your database, should also be in SQL. So whenever you're working with relational databases, it's essential to have at least a basic grasp of SQL in order to be able to store and retrieve data to and from them. Yeah, you can't just do it all with clicking with GUIs, because you obviously have to run it in actual programs, yeah? Now it's complex, right? I mean, years ago when I worked at Trinity Mirror, we actually had to deal with some pretty hairy SQL kind of stuff, right? It's not just simple select statement. You've got like selects and then within other selects, and you can get these really sort of complicated nested statements that are really mess with your head, But we're not going to deal with the sort of real hairy stuff here. Just a very brief introduction to enable you to become familiar. And then if you want to take this further, obviously you can follow tutorials, practice using commands, so on and so forth. So you've actually got a better grip on how it all works, yeah? And just a little tip before I go on, when you're writing code that runs SQL commands, it's always a good idea to dump out the SQL command to, the command to the output of the program, like, console log or whatever, and then check that command works on your actual, by running it in a, either using the MySQL command line tool or using like a graphical interface like Heidi. So test those commands, because, that you've written into your code, because often when you're creating the command, using code like string processing, you can miss like a quotation mark or something somewhere, which can cause it to break. So it's always a good idea to test it using a graphical interface or command line tool, yeah? So in this lecture, I'm just going to go over the basics. What your typical commands that you need to use, almost daily if you're doing this kind of stuff, are insert, select, update, delete. Join is a pretty useful one, so I've thrown that in as well. And then at the end, I'm going to discuss SQL naming conventions. Okay, so let's start with insert. And as you can guess, it inserts data in a specific table, yeah? So you can typically, you're going to want to specify the column names. If you know the primary key as well, if you know all of the columns, if you're putting data into all of the columns, then you can just, do insert into table name, like the second example. But typically you're inserting not the primary key because you're using auto increment to do the primary key. So in that case, you'd specify the table name, brackets, all the column names, and then the values. Now each of these has to match up, right? So value 1 will go into column 1, value 2 into column 2, value 3 into column 3, and so on. Yep. So here's an example. Here's my serials table. So I kind of adapted this. This database is basically a copy of the one I covered in the previous lecture, but here we've got the serials. So each serial has an ID, a name, and a description. I didn't bother with the image URL. Just make my life more complicated for this demo. So suppose I've got this serials table. Then here's an insert table to add a new serial to this table. So I'm doing insert into serials. That's the table I'm inserting into. And these are the columns I'm changing. Two of the providing values for, which is the name and the description. So the values in this case are Tesco cornflakes, which will be stored as the name. Golden flakes of corn will be stored as the description. And so after I run this statement on the database, then I end up with new extra row in the table, Tesco cornflakes with golden flakes of corn. So pretty straightforward. But just to make it clear, let's show you on Heidi. So here on Heidi, I've got on the left, I'm just using this database called SQL Lecture 2. Here's my serials table here. If I look at the data from my serials table, that's the current data. And if you refresh it, I can see that's the data. So let's add some, I don't know, what are the main brands? I've got Morrison's cornflakes. Let's add some Morrison cornflakes, right? So let me get rid of that, yeah. So in Heidi, in the query tab, I can run different queries on the database just as I would run queries if I was doing it within, within a program or something like that, yeah? So let's whack in my query. Okay, so I want to insert into serials. And then here I want to do its name. And rather annoyingly, it also auto-completes name in Heidi, so you might have to do a hack like this, because it's case sensitive, and then description. And then we'll just put the values on a separate page. So the name will be Morrison's. Well, let's not do cornflakes. Let's go. Wow. Let's go. Dogs. Don't care. Tails rice, Krispies, and then obviously, and then puffed rice. Let's say, yeah. Okay, so we got the name and description. So the name here should be that. Description should be puffed rice, and then we press the play button here to run that query on the database. And if it's worked, we can go into serials here and refresh it. And you can see here we've inserted our new kind of serial name and serial description. So that's pretty straightforward. And you'll see that, once you get the hang of it, it's really just a matter of understanding the syntax, like which different bits go where, and then just, then just running it and and you should see if it works or not, yeah? So once we inserted some data, the next thing we're going to want to do is select some data from the table. And we can either choose to select specific columns, or we can just choose to select everything from the table. So we can select everything all at once without any kind of filters. But more commonly, what I'm going to do is I'm going to select specific columns or from a table, and I'm going to have a where condition that determines what I'm going to select. Most of the time, you don't want the entire table, all the data from the table. Most of the time, you want to pick out certain parts of the data in response to, a website query or something like that. Yeah. So our serials thing, I might want to select name from serials. That's picking just a single column there, and then I get all of the names of every single row. Yeah. So again, let's have a little run on that, yeah. So go back to our query tab, and so suppose I want to select everything from the table. And by convention, the commands go in capitals in kind of SQL stuff, yeah. I think it'll probably work, because they're keywords, it'll probably work without capitals, but, generally, yeah, it works without, but particularly when you're writing code for this, stick to capitals for that. And as I'll come to later, just use lowercase for the names of tables and columns and stuff like that, yeah? So select all from serials basically dumps the entire table, yeah? And then I might want to pick out a single row, for example. So I can have a where condition here, where sort of, they're all different, right? So, well, ID equals 2, for example. So it's given me the one with ID equals 2, or if we just select, I think we can, no, that's not going to work. I think comments are, let's just get rid of that for a sec. So let's look at the table again. Okay, or for example, I could do where, I'm just going to have to do the hack on name. Well, let's just test it actually. I don't think it's going to work. Where name equals as the cornflakes. Okay. Okay, so it's not case sensitive, but if I was running code I would definitely want to make sure it was named like that, yeah, just to be on the safe side, yeah. Okay, so that's picked out by name, and I might not want all of the columns. I might want just the description. I mean, because I kind of know the name already, right? So there you go, the description, great tasting cornflakes, yeah? So we can select different columns, and we can provide different conditions to control which columns are returned, yeah? So updates, probably not going to, oh yeah, you will need this actually for your price comparison, but maybe you won't need it for your web service, which is the only place you're going to be using SQL, as explained earlier. So update is where we want to change data in a table. So again, it's very simple, right? We're specifying which table I want to change or update, and then we're setting certain, values for different columns, and we're specifying conditions that will determine where those changes are applied. Yeah. So suppose here I've got Kellogg's cornflakes as a cornflakes, so same old cornflakes here. Suppose I want to change Tesco cornflakes from golden flakes of corn. Maybe the description's changed by the manufacturer. I want to change that to extra tasty cornflakes. So I'm going to update cereals. I'm going to set description to extra tasty cornflakes. And then here's my where condition. It's going to match all the rows where Tesco cornflakes, where the name's Tesco cornflakes. And so when we run that query, we'll get extra tasty cornflakes instead of golden flakes of corn. Yeah. So let's run a demo here. So we want to let's have a look at our data for a sec. Yeah. So let's update Rice Krispies, Kellogg's Rice Krispies. Okay. So we want to update cereals. Sets equal to delicious puffed rice, where like I say, got this unfortunate hackney name. Like I said, you shouldn't really have to bother with this, but I'm just trying to make it as clear as possible. Kellogg's Rice Krispies. Okay, so let's see if that works. So run that query. And usually if you mess up things on Heidi, it'll tell you, yeah? So if I run that, I get some error because I missed out a quotation mark. So read the error message if you do get an error message. I've run that already, yeah? So now if we refresh this page, we hear it's changed from puffed rice to delicious puffed rice, right? So we've modified the thing that we're changing, yeah? Now let's just change it again, actually, to let's change that to great cornflakes. I know it doesn't actually make sense, but just to illustration. No, that's not going to work actually. So sorry, forget that rather stupid idea. Okay, so that's updating. What I was thinking about doing is trying to see if I update multiple ones, but let's not worry about that for now. Yeah, I can't remember whether the update will change all of the rows that match the where condition. Let's try that actually. Maybe not. It's just going to mess up our later demos. But or it may just do the first matching row. There's probably some way of configuring that. Yeah. Let's not go into massive detail here. Yeah. Okay, so next one I want to cover is delete. Again, very useful, right? So here it's pretty simple, right? We'll delete from, we specify a table name and specify a where condition that will pick out the rows in the table that we want to delete, yeah? Now, if I just run this on a database without a where condition, it can end up deleting the entire table. I think Heidi gives you a warning, but you may not get a warning if you're running it on the command, like the command line tools or running it in code. So always make sure you've got a where condition on delete unless you want to clear the entire table, yeah? Because obviously if we're talking customer data, this could be an absolute disaster, yeah? So be super careful with that, yeah? So suppose here I've got a bit of junk here that I want to get rid of, yeah? So what I do is I delete from, specifying the table I want to delete from, and again, where is the condition that will pick out the row that I want to delete, yeah? So if I run that on the table, I get it'll delete the appropriate row, unsurprisingly. So let's just get rid of Kellogg's Rice Krispies here. So here we have delete from cereals, where name equals, I'll just leave it in, rice, sorry, what's the name? I think think it's Kellogg's Rice Krispies, isn't it? Okay, and let's run it. And so if we refresh it, yeah, and then, you know, if there's nothing that matches it, if we try and run it again, it'll just run it, but it won't actually do anything, right? Because we've deleted all the ones that said match that condition. Yeah, so that's the condition, and that's the table that we're going to delete from. Okay, so those are pretty easy, I think. I don't think any of you are going to struggle mightily with any of that. Yeah, and to build your web service, as I'll explain later, you know, you really just need some of those basic ones. Yeah. Now, join is a sort of very useful one. I'm just going to touch on here, but can be a little bit fiddly, so you may need to practice that a little bit to actually get it to work on your particular data. Yeah? In the previous lecture, I explained what foreign keys are, right? So foreign keys are a way in which you can link tables together. So, for example, an customer order can then point to a row in another table that has the details about the customer. Yeah. So basically, one table is referring to another table, and this is known as a foreign key. Yeah. And typically, you include the primary key of one table as a column in another table as the foreign key. Yeah. So in my sort of example of database design in the previous lecture, I had serials, serial boxes, and comparisons. Serial boxes has the serial ID here, which is pointing to the ID of serials, so that I know, so that it's a way of this here is referring to the serial here, and this is how we managed to get it into third normal form, if you remember from that lecture. Yeah. So foreign keys are a way in which a row in one table, a column in one table points to a primary key of another table. Yeah, can probably point to other stuff, but I haven't explored it that deeply myself. Yeah. So here in the serials table, I've got the ID here of each of the different serials, and then the serial boxes table, the serial ID points to the ID here, right? So these can be, so two rows here can point to the same ID here, yeah, because basically Kellogg's cornflakes appears in 500 grams and 1,000 gram boxes. Yeah, hypothetically, I have no idea. I haven't checked this, but that's the idea. Yeah. And so for a specific row, so if we have row 3 here in the serial boxes, this is pointing to Asda cornflakes. So what this is saying is that Asda cornflakes appears in a 750 gram box, as recorded in the serial boxes table. Yeah. So when we've got several tables linked by foreign keys, that might be a brilliant design from a kind of efficiency and consistency point of view, but from a searching point of view, if we're just using basic select statements, it leaves us a bit short. Yeah, if I just run select on a single table like serial boxes, I'm getting a serial ID here, but I've no idea what that's pointing to, right? If I want to show data to the customer, I could run one select here and then some other kind of messy, complicated select, you know, to get all the data about serial IDs. But that's going to require 2 hits on the database and might be quite a slow fiddly thing with a bit of code, right? So if you want to merge data together, it's always better, if possible, to do that at a database level using SQL, because then you just have to hit the database once and you get a single response back from the database. And also the databases are designed so they can do super efficient queries, particularly when you get into different kinds of indexing. So if you set your database up right, you should always be able to run some fairly complicated queries on the database and not have to do all this kind of complicated data merging within code. Yeah, so always try and write better SQL, and that'll let you be more efficient with your code and hit the database less times, which is going to make your web application more efficient if you're writing a web application. Yeah. So the answer to that problem is join. Yeah. So join is a way of linking data from several tables together into a useful result. Yeah, and there's, you know, unsurprisingly perhaps, there's lots of different types of join. So we can, the one I'm going to cover here is inner join, which is looking for entries that exist in both tables, and it will return the results where the entries, like there's a match where there is an actual foreign key relationship between the two tables. Yeah. And you can do a left join, a right join, and a full outer join, which basically returns everything from both tables. And, you know, those are the various kinds of options. But for the moment, since that's probably the most useful one, I'm going to cover inner join. Yeah. So here we're running a select on a particular set of columns from both tables, potentially, and looking for, and it's just going to return the rows and the data that from those columns that exist in both of those tables. Yeah. So the syntax is basically we're selecting the columns, and we have to link those to particular tables, because some tables could have the same column names. Yeah. And then we select one table, and then it will join that table to the other, and then return the matching rows that exist in both tables. Yeah. So suppose I want, you know, in my serials example, I want to know both the name and the size of the cereals that have boxes. So these are kind of, loosely speaking, different types of cereal products that are available. There's Asda cornflakes, Tesco cornflakes, and Kellogg's cornflakes. But these cereals only appear within specific box sizes, right? If I want to buy cereals, I have to buy in a box. And so therefore I need to link together both the cereals with the cereal boxes in order to get the name of all the cereals along with the sizes that those cereals are available in, yeah? That's the idea here, yeah? So here I'm going to want to, so first thing I want to do is select the columns that I want to extract. Yeah, so I want to get the name here, as I've said, and I also want to get the size column. Obviously I could get the ID or the description, blah, 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 but here's, for the illustrative purposes, we're just going to pull the name of the cereal and the size of the cereal here, yeah? Now we select the first table that we want to pull the data from, that's our cereals table here, and then we're linking it to the second table here, that's what the inner join statement's doing here. And then this is the rule for the inner joining, yeah? It's saying where serial ID equals ID, then that will be a row from cereals that we're going to include, and then we'll pull in that size data for that row, yeah? That's the idea here, yeah? And you can see here the result. We now know that Kellogg's cornflakes appears in 500 and 1000, that's because it's joining this one matches this one here, this one matches this one here. And as the cornflakes is joined here, so we can see here, as the cornflakes appears in 750 gram box, and Tesco cornflakes, as yet, has not been boxed according to this database, so we're not getting rows returned from the Tesco box, from the Asda box, not getting any rows returned for the Tesco cornflakes because no box has been specified. Remember, it only returns rows that match both of the tables. Yeah. Okay, so let's run a inner join just to sort of illustrate it. It'll be pretty much the same one, and I'm going to have to remind myself the syntax because I always forget this. So from cereals inner join. And then there's the condition. I probably have to go back to that because I tend to forget this almost as rapidly as I read it. Right, so let's do select. Let's do slightly different. So cereals dot name, cereals dot description from cereals. Yeah. So that's the basic, right? You know, that's what we'd get if we just ran that, right? I think we're just going to get the cereals name, cereals description, right? So far, so inner join. I don't know if I need on there, do I? Nope. Inner join. So I'm going to join it with cereal boxes, right? And then we want cereals.id equals, let's just check this, equals cereal boxes ID, yeah. So we're selecting these two columns, yeah. Oh, and I want, actually I want cereal boxes.size, cereal boxes.size, yeah. So I also want the sizes right, and I'm selecting from the cereals and joining those results with here. It'll go through these results, and for every one where cereals ID equals cereals boxes ID, it'll return that result, yeah? So here we're getting the name, the description as requested, and the size. And then, like I said before, it's not returning the data about Tesco cornflakes because that doesn't actually have a box associated with it, yeah? So play around with this, and you can even sort of merge more tables than one. You can select from a selection and so on and so forth. That's where we're getting into much more hairy SQL. This is just an introduction, so I'm not going to cover that here. You know, if you're struggling to get a super cool query that has like multiple selects and all that, then maybe you could just write it in code and do it in a simpler way, yeah? There's no sort of, not expecting you to do really difficult stuff for this coursework, yeah? With SQL, that is, yeah? So yeah, SQL, it's rich. I've just covered the basics here, right? This is just very, if you can manage these, then you can build your web application, and that's fine, yeah? Your web service, sorry. But there's a lot more to SQL, which is why, you know, it's top in jobs. If it was as simple as I've shown you, then there wouldn't be lots of jobs in it, right? So to get better, and maybe when you're practicing for interviews, if you're in an interview with SQL as one of the requirements, obviously you want to follow some tutorials, read more about it. There's loads of books on this, you know, tons and tons of video tutorials and so on and so forth, yeah? And when you're actually using SQL, you'll find that it's well worthwhile looking at the documentation for it, because that gives you all of the different options and all the different ways of doing it. Yeah, so if you look here, you've got select, all the different possibilities, and you'll find things that are really useful, right? So for example, with the web service for coursework 1, I'm expecting you to be able to have limit and offset, for example, and then that means you can build into your SQL select, you can limit the number of items returned, and you can offset it so you can get different, so you can do the pagination with the web service effectively, yeah? And by doing the ordering, you can like order by, you know, price or alphabetically and so on and so forth. Yeah, so you'll find that when you look into the documentation for these different SQL commands, you'll find lots of extra bits and bobs that will make your life a lot easier once you've actually mastered them, yeah? So the final thing I want to cover in this lecture is SQL naming conventions, right? So SQL is a fairly rich data interface language, I guess, not really a programming language, but data interface language. And so you will end up both, you know, with writing SQL scripts. You'll have a bunch of code that will use these use SQL in different ways. And as mentioned before, you know, code is a team effort, right? You're almost always writing code as part of a group. Your databases, your code, your SQL scripts, they're going to be viewed and maintained by people possibly long after your death. You know, there's an awful lot of code drifting around from, you know, let's say the 90s, you know, in banking systems and so on, that unfortunate people now have to go back and try and maintain in various obscure programming languages, yeah? So if you're thinking about code as a team effort with code is always much, much easier if there's certain naming conventions, right? Because if you name your database columns with, you know, capitals and someone names them with, you know, lowercase, or you use underscore, another person tries to use camel case, that's going to get really messy because they're going to have certain expectations when they look at your code and try and write more code or maintain your code if you're using a different convention from what the person maintaining your code will use, yeah? So always, 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 with any programming language, stick to the standard naming conventions, in this case the SQL naming conventions. Ensure everything in your database in SQL scripts is as clear and consistent as possible, yeah? Treat this as you would treat any programming language. Use the conventions and use lots of comments where appropriate, yeah? Now, the naming conventions for SQL are to only use letters, numbers, and underscores. So no camel case in SQL because I don't think it's case sensitive. And so therefore you're going to get in a mess. You're going to be much harder to read and much easier to get in messes if things are, you know, mixtures of uppercase and lowercase. So always use lowercase. And because we can't use camel case, we have to separate words with an underscore, yeah? Don't use words that are data types because there are certain reserved words with SQL and the system will just get messed up if you try and use them. Try not to use abbreviations. You might think it's cooler to use MDL, NME, right? But someone reading that, you know, who is not familiar might think it means something else, right? And I bet you if you come back to that a year later and look at it and be like, MDL, name me, what on earth does that mean, right? Whereas if you write middle name, sure, you've got to type a few extra characters, but the code will be that much more maintainable and it'll make your life and other people's lives that much easier, yeah? Avoid reserved words, user, lock, table, etc. Again, the system, you're just going to break this, you know, your code's just going to break, the system's just not going to work, yeah? So have a look at these two style guides. The links are in the resources for this week, yeah? They're not always consistent, but as a general rule, if you stick to lowercase, underscores, for everything to do with your names of tables, columns, and so on and so forth, then you should be fine, yeah? And again, abbreviations, obviously at some point, if you've got like 50 characters, you need to abbreviate it. But for most stuff, you should be able to get away with, you know, giving the full words. And just as a general tip, don't name your columns using the name of the table. Yeah, you know that the column's in the table. I should have put an example into here. But if you wouldn't call in fact, I'll try and give an example here I'll just type it in here, yeah. So if you had a column, so I've often seen this. So suppose we've got a column called ID, name, description, etc. Yeah, I've often, and suppose this is in a table called serials. I've often seen people do this kind of stuff. Yeah, serial name and serial description. Yeah, completely unnecessary, right? Because we know that ID, name, and description are columns in the serial table. That's fixed by the whole structure of the relational database. So please don't do this. Yeah, ID is perfectly fine for ID, name, and description. Even if if you're trying to reference that in another from a script or command that's running across it, then obviously you're going to do something like serials.name, right, in order to reference that specific name within the serials table, yeah? So don't ever name things using the name of the table. There's absolutely no need for that, yeah? Okay. Now there's marks because I'm trying to encourage good practice, right? So there's marks for using sensible naming conventions in your coursework. Yeah, so a couple of marks, and you'll benefit from it, and your colleagues will thank you for it as well. Yeah. Now within coursework 1, there's you don't have to use SQL everywhere, right? So in your Java web scraping application is using Hibernate, this object relational mapping framework, it's called, I think, to store and retrieve data. Yeah, because if you ever write lots of code that's dealing with lots of SQL, you'll find that it actually gets quite messy, right? You have code and you have endless strings of SQL that are put together by bits of code, and eventually mistakes will be introduced. It's harder to move database and so on and so forth. So Hibernate is a framework that sits between the Java code and the SQL database and relational database, and it handles, what Hibernate does is it generates all the SQL for you, and then all you have to do is work with a simplified sort of Hibernate interface. Yeah. So for your Java application, you're not going to be dealing with SQL, so you don't need to worry about all this stuff I cover in this lecture for Hibernate. It's good to be familiar with it because Hibernate will generate the SQL that you're using, and you might want to test that out to debug some of the stuff. So it's good to be familiar with SQL for that part of it, but it's not, you don't write any SQL code for your Java application. You will lose marks if you do that. On the web service side, I anticipate, because all my examples are based on that you'll use JavaScript running within Node to generate strings of SQL and then run them on the MySQL database in this case, yeah. And that's a very standard way of working, not the most maintainable. But if you're really keen on using these object relational mapping frameworks, you can, for example, use Sequelize or a similar thing, which will basically do the same job, that you'll interact programmatically with JavaScript objects, and behind the scenes Sequelize will generate the SQL for you. You don't have to do that. It'll probably make it be more complicated for you to do that, and not really worth it on such a small system. But if you really want to, you're welcome to use Sequelize, yeah? So I'm anticipating you using SQL commands in your JavaScript, but definitely not in your Java, yeah? And just be clear about that, yeah? Okay, so in this lecture, I've covered the structured query language, or SQL, that's used to store and retrieve data to and from relational databases. I've covered some of the basic SQL commands, some of which you're almost certainly going to use to build your web service as part of your price comparison websites. It's quite a popular programming language in the industry still. You might have thought that kind of NoSQL databases would have taken over, but that's not the case, right? Firstly, there's an awful lot of legacy code based on SQL. And secondly, for certain kinds of application, like banking systems, government systems, so on and so forth, where the data is very well defined and you want to make sure that there's consistency between the data, then SQL is the right choice of database for those kind of applications, yeah? SQL has naming conventions that you should follow in your coursework and elsewhere, both because there's marks associated with it for your coursework, but more importantly because the rest of your team will find it much easier to work with you if you stick to the standard naming conventions for SQL. That's it.